Alright guys, we're going to graph and find some critical values of this log. I have log base 3 of x plus 2. First I see my transformations. I went left two. So that tells me that my asymptote is the line x equals a negative 2. So at the negative 2, I'm going to have a vertical asymptote that I cannot touch. Now I need to get some points. In order to do that, we're going to go to our calculator. Let me see if I can make room for the calculator here. There we go. Go to my table feature. Clear that out. I have to put this in using change of base. So it's going to be log of x plus 2, close parenthesis, over log of the base. Close that up. So there we go, using change of base formula, I successfully input that in there. Let's see what this looks like. I'm going to start at negative 2, step by 1. Enter, and now I got some points. At negative 2 I've got an error, and I was expecting one there because when x equals negative 2, that is my asymptote. I can't have a point on that line. Jot down some points here the best that we can. I know that at negative 2 I am undefined. That's fine. At negative 1 I'm at 0. Scroll down here at 1, I'm at 1. Well, I skipped a critical point here. Let's go back and put that in here. I'm at 0, I'm at 0.63. And let's see if we can get one more good point maybe before we're done. At 7, I'm at 2. Alright, so I'm going to plot the points. Negative 1, 0. 0.63, so it's a little bit more than halfway up here. 1, 1. And 7, 2. Okay, now you kind of got to draw a smooth curve through the points the best you can, and at the end it's going to drop sharply and approach my asymptote as I fall. Okay, my domain for logs are restricted because the range for my exponentials are restricted. So my domain coming in from the left, first thing I see is my asymptote at negative 2. And I continue on to the right towards positive infinity. I can't touch the asymptote or infinity, so those are both soft parentheses. My range for all of my logs, coming in from the bottom, negative infinity, and I leave going to positive infinity. So the range for all of my logs is negative to positive infinity. Remember we said for exponential equations, the domain was negative to positive infinity. Because exponentials and logs are inverses one another, they swap domain and range. X-intercept. My x-intercept's right here at the negative 1. So that is negative 1, comma 0. My y-intercept, I almost skipped it up here. That is 0, comma 0.63. Increasing or decreasing function. This is an increasing function. When is it increasing? It's increasing along its domain. So it's increasing from negative 2 to infinity. Is it ever decreasing? No, none. NA, whatever you want to put there. In behavior. This one's a little trickier for the logs. So let's see if I can type this out so you guys have a better chance of reading this. And I'm going to scroll it up a little bit as well. There we go. In behavior. As x approaches blank, f of x approaches blank. And got to do the same thing one more time. As x approaches blank, f of x approaches blank. Now we can fill in the blanks. Alrighty, so here we go. As x approaches, going to the left, we'll start to the left first. So as I go to the left, how far to the left can I go? I can only go as far as my asymptote. So as x approaches the asymptote at -2. So as I move to the left towards the asymptote, what does the function do? The curve, the function, goes down towards negative infinities for the y's. As x goes to the right towards positive infinity, f of x also goes up towards positive infinity. So for a log function, what we will find is that for the first part of this, one of these will be our asymptote, and another one will be one of our infinities. It just depends on the picture. Over here on this part, f of x is going to approach one of the infinities. Okay, just got to pay attention to the picture.